Now you just learned that there are two important operations with sets: set intersection and set union. And to find the intersection of two sets, we want to find the element in common in both sets. And with set union, we would like to find all of the elements contained in both sets. So let's next consider some examples where we need to find the intersection of two sets. And in our first example, you can see we have the set consisting of the elements 1, 2, 3, and 4. And the second set contains the elements 3, 4, 5, and 6. Now we want to first observe that both of these sets are discrete sets because the elements can be listed separately in each. So now what we look for will be those elements that are in common. I think you can see that first we have the element 3 in common and also the element 4. So then we will write then for the intersection of these two sets, the set consisting of the elements 3 and 4. Now our next example consists of two sets that we would call continuous sets because there are infinitely many numbers, if you will, in each set. And it's often helpful in these cases, I think, to use the number line to help us decide what the intersection is. It's a little more visual way to help us in that final determination. So what we have in our first set is the set in green consisting of all the elements between -3 and 5. And the parentheses indicate that the endpoints are not included, so everything between -3 and 5, but not including -3 and 5. And our second set consists of all the elements between 1 and 8, but not including 1 and 8. So you can see that each of those sets is graphed below, the first in green above the number line and the second in blue below the number line. So if we visually look, then what we're trying to find then would be the points that are in common, which would be then where did these two graphs overlap essentially. So I trust you'll agree that they would overlap between the elements 1 and 5. So let's next then draw the graph on the number line itself. So the intersection then would consist of all the elements between 1 and 5, not including 1 and not including 5. So then we can write then that the intersection in interval notation would be then in between 1 and 5. You notice I need to make that a little bit more clear down there where the 5 is. Now our third example, consists of the sets from -infinity to 7, including 7, and you notice the bracket there which tells us it includes 7. And the second set in blue consists of all the elements from 7 to infinity. So the first graph is, the first set is graphed in green below, and it's above the number line, and the blue graph then down below is the graph of the set from 7 to infinity. Now, if you look at where these two graphs overlap or intersect or have points in common, I think you can see that the only place that will happen will be actually at the number 7 itself. So then we would write that the intersection of these two sets consists of just the number 7. Now in our next example, we have the set -infinity to 7, including 7. And the second set is 17 to infinity, including 17. And so the first set is graphed above the number line, you'll see there in green. And the second set is graphed in blue below the number line. So where do these two graphs overlap? And you can see, well, they don't. So that would tell us then that there is no intersection of these two sets. So what we would write then is that the intersection is the empty set, which you know can be written as a circle with a line through it, or we can simply write two braces with nothing inside. In our last example, we have the sets -3 to infinity and 3 to infinity. And the first set is graphed, you'll see in green above the number line, and the second set is graphed in blue below the number line. Now visually look to see where those two graphs overlap. And hopefully you'll see it actually will be from 3 to infinity, which is the same as all the elements in the second set. So what we'll do then is to show the intersection itself on the number line. So the intersection is graphed in red, and then what we can write then is that the intersection of these two sets expressed in interval notation would be then the set from 3 to infinity.